Hello everyone, I am Dr. VRAO. In the previous lectures of thermodynamics, we have had gone through the first law of thermodynamics, heat capacities. And in this lecture, we are going to learn drawbacks in the first law of thermodynamics and reasons behind to go for second law of thermodynamics and spontaneous processes, right? So actually the basic point of first law of thermodynamics is that physical or chemical processes takes place in such a manner so that the energy of this universe remains constant. I repeat, the basic point of first law of thermodynamics is that physical or chemical processes takes place in such a manner so that the total energy of the universe remains constant. That is, from that we can understand that first law fails to predict the direction of the change or feasibility of a process, right? So from that above statement, from the earlier statement, from the basic point of the first law of thermodynamics, we can conclude that first law fails to predict the what is the direction of the change or feasibility of a process. For example, a hot object cools down to the temperature of the surroundings, right? A hot object cools down to the temperature of the surroundings, but a object does not become hot than its surroundings. I repeat, a hot object cools down to the temperature of the surroundings, but a object which does not become hot than its surroundings. We can understand with a daily life example. For example, if you take a cup of hot tea is kept in a room, right? You please listen my words very carefully. When, for example, if we take a cup of hot tea kept in a room, that cools down spontaneously on its own. But a cup of tea does not become hot on its own, right? I repeat, a cup of hot tea kept in a room cools down spontaneously on its own. In this case, first law holds good, because when the cup of hot tea loses its heat to the surroundings, and surroundings gain the energy, gain that heat energy. So total energy of the system remains constant. So the heat lost by the cup of hot tea is gained by its surroundings, right? But a cup of tea does not become hot than its surroundings. In this case also first law holds good, provided if the surroundings lost heat and that heat is gained by system, right? So you catch my point. A cup of tea does not become hot than its surroundings. In this case also first law holds good, provided if the surroundings lost the heat and that heat lost by the surroundings gained by the system, then first law holds good. But it never happened. So, and one more example is a gas expands in the space available. A gas expands the space available, but the gas does not contract to the smaller volume on its own. I repeat, a gas expands to the space available on its own, but a gas does not contract to the smaller volume on its own, right. So, this is the drawback of first law of thermodynamics. Another drawback of first law of thermodynamics is it fails to explain the extent of change. It fails to explain the extent of change, that is, it fails to explain the extent of the conversion of heat into work is possible, or vice versa. I repeat, you do not confuse with this statement. First law fails to explain the extent of conversion of heat into work is to what extent. First law fails to explain the to what extent of conversion of heat into work is possible, or vice versa, right. So, in simple words, first law concludes that whole heat cannot be converted into work, that is all. First law concludes that, and the first law concludes that whole heat cannot be converted into work. So, that means it fails to explain the extent to which the conversion of heat into work is possible, or vice versa. So, these are the two drawbacks of first law. That is, first drawback is it fails to explain the direction of change or feasibility of a process, and it fails to explain the extent to which the conversion of heat into work. These are the two drawbacks of first law of thermodynamics, and these drawbacks are overcome by second law of thermodynamics. And the feasibility of a process or a spontaneity or spontaneous process can be explained by second law of thermodynamics. So, these are the reasons, that is, these drawbacks are the reasons to go for second law of thermodynamics. Okay. So, before we are going to learn second law of thermodynamics, we should have an idea on spontaneity or spontaneous process, spontaneity or a spontaneous process, right. We should know we should have an idea on what is spontaneity or spontaneous process. Spontaneous process or spontaneity, right. Let us I shall try to make clear the what is a spontaneous process, right. In our daily life, we come across from many natural processes that occurs on its own in one direction only. I repeat, in our daily life, many natural processes that occur on its own in one direction only. For example, a cup of hot tea cools down to the temperature of the surroundings on its own. A cup of hot tea cools down to the temperature of the surroundings on its own, right. And the second example is a gas expands to the space available on its own. And the third example is water falls down from the hill on its own. Water falls down from the hill on its own. right. This is the very important example by which we can understand this spontaneous process. A water falls down from the hill on its own. So, by observing these three examples, hot tea example and gas expansion example, and the third one is water falls down from the hill on its own. In these three processes, or in these three cases, these three occurs on its own. Therefore, spontaneous process can be defined as, spontaneous process is the process which can occur without work being done on it, right. Spontaneous process is the process which can occur without work being done on it, right. So, without the work, those processes takes place on its own. And moreover, it should be noted, it should be kept in your mind that a spontaneous process does not mean that it occurs instantaneously. It should be noted that a spontaneous process does not mean that it occurs instantaneously. It is a process which has a tendency to occur. It is a process which has a natural tendency to occur. For example, water at a hill falls down to the bottom. It has a natural tendency to occur. For example, if you place a cup of hot tea in the room, that automatically cools down to the temperature of surroundings. It is a natural tendency. It is a natural tendency. So, spontaneous process which has a natural tendency to occur. Therefore, so spontaneous process is the process which has a natural tendency to occur. Therefore, spontaneous process is the process which can occur without work being done on it, right, without work being done on it. Next, one more thing is there are some processes which cannot occur on its own and are made to occur by supplying heat from the surroundings, by supplying energy from the outside, and made to occur. Those are called non-spontaneous processes, right. So, there are some processes which do not occur on its own and are made to occur by supplying energy from outside and made to occur. Those processes are called non-spontaneous processes. Therefore, non-spontaneous processes are the processes that can occur by supplying energy from the outside, but spontaneous processes are the processes which can occur on its own without work being done on it, or without the supplying energy. Without supplying energy from the outside, that spontaneous process can take place on its own, right. So, I hope you got the idea of, I hope you got awareness on spontaneous process. So, spontaneous process is the process which has a natural tendency to occur, but actually the actual rate of the process may be varied from very slow to extremely fast, right. But the actual rate of the spontaneous process may be ranging from very slow to extremely fast, right. So, now how this spontaneous processes is represented? How can we represent this spontaneous process? Next question is how can we represent the spontaneous process? Already we know that a spontaneous process has a potential to occur on its own in one direction only. Already we know that spontaneous process has potential to occur on its own in single direction. That means we can understand there must be a kind of driving force. There must be a kind of driving force behind the spontaneous process. For example, take the best example to explain the spontaneous process, that is water falls down from the hill. Water falls down from the hill. That can occur on its own without work being done on it, or without supplying energy from the outside. Water falls down from hill, right? So take this, this is the hill station. For example, you take this is the hill station, and water at this hill station comes to the ground on its own, that is without supplying energy. Okay, and you should keep this point in your mind. In our universe, most of these systems are likely to get stability. Most of the systems are in our system, in our universe, every system try to get stability. Every system try to get stability. For example, why this stability concept is introduced? Because water flows down from the hill, that is water at the hill station or water at the high level. Water at the high level has highest energy because of its height. So water at the hill station or water at the top of the hill, that has a more potential energy because of height. You know the potential energy formula, mgh. With increasing the height, we can increase the potential energy of the system. So the energy of the water at this high level, at this top, is more. So maximum energy, and system corresponds to high energy has most maximum instability. System corresponds to maximum energy. Highest energy corresponds to lowest stability, and systems corresponds to lowest energy has maximum stability. So water at this hill station or water at the top of the hill has higher energy but less stability. Okay, but water at the lower level has lowest energy but maximum stability. But the point is, in our universe, every system try to get stability. So whenever the water at the hill, or the water at the high level or the top of the hill has more energy, that more energy drives the process to occur spontaneously. That high energy, that is the energy at the high level of the hill, drives the process to occur spontaneously, because at that higher energy system possesses lowest stability, but if it goes to the lowest energy, that gains maximum stability. Owing to that reason, that the maximum energy drives the process to occur spontaneously. So the extra energy, the high energy at the top of the hill station drives the water flows down to the hill, right? Okay, so system with maximum energy corresponds to minimum stability, right? Minimum energy corresponds to maximum stability. So the water at the hill station or water at the top of the hill has maximum energy but minimum stability. So this maximum energy, that high energy drives the process or drives the water to flow down to the bottom, that is flows down to the earth, right? Okay, so at the lower level water has lowest energy and maximum stability. Due to the higher energy at the higher level drives the process to occur spontaneously. So in this spontaneous process, this is system, that is the water flowing down from the hill, that is our system, loss its energy. That loss is represented with a negative sign. But the energy changes. All these processes, all natural processes takes place at constant atmospheric pressure. That is constant pressure. So the energy changes takes place at a constant pressure, that is that can be represented with enthalpy changes. Okay, that is enthalpy changes. So energy changes that takes place at a constant pressure is represented with enthalpy change. So these energy changes, because all these energy changes takes place at a constant pressure, that's why these energy changes can be represented with delta H. But during this process, this system lost its energy. So that loss of energy is represented by minus delta H. That's why regularly if delta H is negative, that is a spontaneous process. Always we often tells that delta H is negative, that is a spontaneous process. But the reason is delta H negative means that is that during the spontaneous process that system loses its energy, right? System loses its energy. But there is a important point, that is but there are some processes which takes place spontaneously but whose delta H is positive. Okay, but there are some processes which takes place spontaneously even though delta H is positive. Delta H positive means even though the system getting energy, actually in the spontaneous process what happens? Any process, we can define the spontaneous process. How can we define the spontaneous process? Any process which involves decrease in energy is a spontaneous process. Any process which involves decrease in energy is called spontaneous process. But there are some processes which occur spontaneously even though the delta H values are positive. Even though delta H values are positive, that process takes place spontaneously. What are the examples? Best example is evaporation of water in the lake. Evaporation of water in the lake or in the pond. This is the general observation. General example, evaporation of water in the pond. So, evaporation of water in the pond, when it happens? So, in our daily life, in our general observation, water is getting evaporated from the pond. We know that. But when the sunlight or something, it is continuously getting energy from sun. It is continuously getting energy. It does not lose its energy. It does not lose its energy, but it takes place spontaneously. But what we know from the earlier discussion, a spontaneous process is the process which involves decrease in energy, but evaporation of water from the pond is gaining energy actually from the sun. It is gaining energy and it is getting heat energy from the sun. It does not lose heat energy, it is getting heat energy from the surroundings, but the process takes place spontaneously. So there is another factor which decides the spontaneity. There is another factor which decides the spontaneity. In the earlier case, the deciding factor is energy, but here another factor is deciding the spontaneity. That is, when water is getting evaporated from the pond, what happens? Water is in the liquid state, we all know. Okay, water is in the liquid state where the liquid water molecules are close to one another. Where in liquid, that is in water, water is in the form of liquid where water molecules are close to one another. When these water molecules are getting evaporated, when these water molecules are getting evaporated, what happens? When the water is getting evaporated, that vapor water molecules, the water molecules in the vapor, what is it called? The water molecules in the vapor state occupies the space available, occupies the entire space that is available for them. So, the water molecules are far away from one another. In the liquid state, water molecules are close to one another. Those are close to one another. But when we compare with the solids, in solid state, that is ice cube, water molecules are close to one another, very close to one another. But in liquid state, water molecules are far apart from one another, far apart from one another. But in the gaseous state, water molecules are very far from one another. That means when liquid water is getting evaporated, these water molecules in the vapor state occupies the space available to them, like the gas expands the space available, like the gas expands or the gas occupies the space available. Like similarly, these water molecules, the water molecules are getting evaporated in liquid water molecules getting evaporated, water molecules in the vapor state occupies to the more volume, that is water molecules are separated by large distances, that is water molecules in the vapor state has a random orientation, that is randomness. Water molecules are randomly distributed. So, in the evaporation of water, from pond occurs spontaneously, and that driving force is whenever the water molecules are getting evaporated, that water molecules in the vapor state occupies the space available. Owing to that, randomness increases. That randomness is the driving force for the spontaneity. So, therefore, for spontaneity there are two factors. One is tendency to a state of minimum energy, tendency to a state of maximum randomness. Okay. So, these are the two important factors, that is tendency to a state of minimum energy or maximum stability. Minimum energy, maximum stability, tendency to get a state of minimum energy, that is decrease in energy, and tendency to a state of maximum randomness, that is maximum randomness. These are the two driving factors for spontaneity. Okay. This maximum randomness is called entropy. Okay. In our terminology, in thermodynamics terminology, that maximum randomness is called entropy, right? So, I hope you learned something from this lecture, and in the next video we will learn second law of thermodynamics. Okay, I hope you learned something, and if you really learned something, please extend your support by like, share, comment and subscribe. Thank you for watching.